We're honored to have Hasan Yasar, the Technical Director of the Continuous Deployment of Capability Group at the renowned Software Engineering Institute at Carnegie Mellon University. With over 25 years of experience in secure software development, Hasan is at the forefront of leveraging emerging tech like DevSecOps, AI, ML, and more to drive transformation in software development. He's a seasoned security engineer and software architect who imparts his vast knowledge as an adjunct faculty member at CMU, teaching software and security and DevOps courses. In today's episode, we'll delve into Hasan's journey into the world of SBOM and explore its significance in complex systems, especially in highly regulated environments. We'll also discuss the concept of an actionable SBOM, the various types of SBOMs, and how DevSecOps can play a pivotal role in enhancing security. So, without further ado, let's dive into this enlightening conversation with Hasan Yasar.
How do you create security champions? Security Journey brings together two powerful approaches to provide application security education to help developers become security champions and produce safer applications. Security Journey training content extends beyond developers to reach the entire SDLC, creating a security-first organization. Learn more about our enterprise security training at securityjourney.com.
Hey folks, welcome to another episode of the Application Security Podcast. This is Chris Romeo. I am the CEO / general partner of Kerr Ventures, and I am also the CEO of a stealth cybersecurity startup. I know it sounds very mysterious, but there will be information released soon. Also joined by my co-host and good friend, Robert Hurlbut. Hey, Robert.
Hey, Chris. Yeah, Robert Hurlbut. I'm a principal application security architect and threat modeling lead at Acquia, and really glad to be here again for another great podcast.
Yeah, we're going to unpack SBOM. As our listeners know, one of my favorite things to talk about. Looking forward to it here. Super excited to have Hasan Yasar with us today. Hasan, we like to jump right in with security origin story, giving you no time to warm up whatsoever. How'd you get into this world of security?
All right, it's a long journey. Actually, we have been in security since I started writing a program almost 1993. But we never really maybe say clearly about the security as kind of what top requirements, but I have been dealing with writing a software mainly for F-16 simulators or the aircrafts. We have to have a security as by design. However, when we get into the more industry places, and I kind of started drop the security because business was more driver for the functionality, then I did a lot of IT-related work in industry, and I came to the CMU, Carnegie Mellon University, as the division of the forensic division as part of the CERT, Computer Emergency Response Team, part of the SCI and CMU. Then I brought my industry experience years and said, wow, we're going to do something here is important by thinking security, not just looking for a forensic perspective, really taking that application context and get into our original thinking of softwares and engineerings and all the complexities. Now we have to really clearly talk about security as we are building application. That's what I kind of get back into the security world as starting at the CMU 2010 as part of the CERT and try to build up application security as we are building application. Around that time frame, DevOps started as kind of a thing in the community, as kind of another myth or whatever you call for DevOps, and became a reality, and how the business functionality is pushing a lot of security minds, like business thinking. Now, actual security became like kind of more ignored in the community perspective, as well as the business drivers. And I built up the DevSecOps concept as part of CERT and CMU, said, no, we have to do Sec as part of DevOps. We have to do security as part of application security. We have to do the secure concept as by design. Now there are a lot of opportunities. At the old days was very difficult because we have limited tools, limited practices, and we were not able to do a lot of security thinking. Now there is an opportunity for all of us as a community members. We can use either DevOps concept or Agile concept or a SAFe or anything we do, software engineering, Now there's an ability to get the security into our practice. That's kind of my daytime job, doing a lot of DevSecOps and supporting various Department of Defense organizations and programs, as well as teaching at the CMU, software security course and DevOps course. And I saw how important to have security and also how easy to use the security as part of software engineering practices when we think about at the beginning. That's what I'm trying to do, Chris.
Okay. So, I have a couple questions before we even start talking about SBOM.
Absolutely.
Caught my attention when you mentioned F-16 simulators and secure by design. When you think about building software for an F-16 simulator, how is that different than building software for a web application?
It's a big difference. Why? Because when you think about a simulators or any type of complex system, Chris, we are not doing a lot of kind of a very architected or different layers of applications. We are writing the code from literally an interface layer up to the functionalities, either using a C, C++ as an example. We were kind of at engineering, we have to think about all the stack and as well as all the functionalities from memory management all the way to the kind of users click the button, etc. It has to be completely controlled. It is great. Think about that perspective because we don't know other dependencies. We have to write everything from scratch. As an engineers, it's requiring a lot of team coordinations. The security focus was more on making sure that we are addressing the safety and criticality as we write in the code. Safety and security was kind of parallel in that world because when you're dealing about a flight, as an example, you have to have a safety. What the safety means, memory management. What the safety means about timing. What the safety means, we can write the code with that those qualities should be part of it, which is kind of a by design as security as a safety together. When we look at the web application now, we are dealing with just the tip of the iceberg. We don't know other dependencies a lot. Like we're just writing a code in AngularJS. It is running on such web services. How much do we have a control of web services? How much do we have a control of the dependencies on infrastructure? So the coding seems much easier to write in the web applications. Easier means like a less timing, but we don't have a control on the code. Comparing the 15, 20 years ago, almost 30 years ago, honestly, when I write the first time the code in C++, we have full control. It takes longer to write the code. It takes longer to verify the code and test the code. That's kind of a dilemma we are dealing right now, like time and control. Which one are we going to choose? Do we have to go fast and fast, has less control? Or do we have to control the application, but it takes a little bit longer? That's kind of a more directional people are looking for. If you look at the CIS as an example, I'm sure you heard about it, that now we are looking for more Rust language as the memory safety language, to replacing some of the code bases. To find a balance between time and control, Chris, what I have been seeing in the community.
Yeah, and I guess in the world of F-16s, even though it's a simulator, the stakes are so much higher than, and you could say that the stakes in a web application that processes credit card information and stores that potentially in a database, the stakes are high for that. But that's not a life and death situation.
Correct.
Whereas F-16s and the software that is driving them, and I know you're talking about a simulator, but it just seems like the stakes are higher.
It is higher, and in reality, when it is simulator, we're using the same code base for actual flight.
Okay.
One is really running on emulators and or using a machine as on ground. The other one is actually running on a machine, which is the flies basically aircraft is flying. So it's the same code base, but interface or the machine is really running on the ground. So all the interfaces as same as running on aircraft, like radar systems or the heads-up display or the connectivities for each of the control units are exactly the same mimic or same configuration using the same instruments. It is not that just I know you remember the old Microsoft Flight Simulator. It is not like just the computer graphics. We were dealing the actual cockpit with all the instruments are interacting with the radar unit or air and altitude or other type of units. It's kind of interacting each other. Difference is running on the ground. So it's kind of maybe I can say high fidelity of the simulators. So in that sense, we have to think about it. Here's the impact of that thinking also. If we train the pilots, if there is any timing of the training pieces, they cannot develop the skills, then they can run the actual aircraft and be so quick in a matter of seconds. It's a life situation. Like if they don't decide, if they don't learn enough on dealing some indicators on the cockpit or in dealing indicators some of the other in kind of interfaces or unit that's coming a message from the other components, it is very difficult to pilot to decide on the flight. So they have to learn those skills when they're practicing simulator. That's the impact of the flight and kind of that situation or a risk situation.
Yeah.
So when we take that the concept, actually, maybe we're going to discuss later on, it's becoming very, very important now if we are dealing with the safety critical systems. Now look at every devices we are on the street and driving the cars. It's the same situation. We are dealing about the self-driving cars. It's a life-threatening situations that we have to think about. Or we are depending on some devices that we're using in our home, or maybe the car that we are using it, or the flight we are taking. There's many, many other complex systems is evolving. So now comparing web, yes, it is, but it may not be affecting my life unless if I'm using something, either medical device or kind of a driving or flying on that device.
Yeah. And we're heading towards a world where there's such more software that's going to be surrounding us, and we already have it now. We have to stop and think about how much software runs around us. But I wanted to catch one more topic before we dive into SBOMs, because I know you're coming from the university world and you're teaching classes in software security, which is incredible. Like, I love to hear that we have professors teaching these subjects, but in general, when I look across academia, I still see a real hole in us teaching security to undergrad students specifically. Like I hear from students, and I have this favorite question whenever I meet a CS student, doesn't matter what university they're from. I always ask them the same question. What have you learned about security in your degree program? And often I still hear networks. We do a class on network security, and I'm like, okay, that's great, but we're teaching Java coding or Python coding. We're not doing secure coding with Python, secure coding with Java. So what's been your experience as somebody who's a lot closer to academia today than I am? Are things getting better when it comes to teaching security to undergrads?
So I'm teaching at the graduate level, Chris, and I'm teaching at the program, which is the graduate level. My students coming from all around the world to the graduate level courses what I teach. I see a kind of year by year and undergrad students becoming, as a graduate student, more knowledgeable in security. Maybe just a kind of a community it's becoming more aware of the security content because it's affecting our life now. It's affecting our ability. Now the students are learning either forcing from a curriculum perspective or learning from where they work, what they do. So I don't see still as very well or teach or taught by the kind of undergrad level yet, Chris. Even the CMU, Carnegie Mellon University, we don't have a specific security class under CS department as the undergrad level. All the courses security is basic graduate level courses. So there are a couple of reasons, my opinion is, why we're not able to teach as undergrad. There are maybe some others like a basic foundational concept, but there isn't any kind of approval accreditations comes from a university level that you can put the cybersecurity as part of undergraduate level. There's one kind of like every university has to go approval process. When they look at the CS or other departments, there's certain classes has to be taught to get approval from IEEE and ISO. There is a disconnect between the organizations who are approving the accreditation of those courses, but there is no room for the security yet. So what's happening, like students are taking as graduate class when they're in the senior level, that's happening in CMU, and CMU is letting the people, like interested students who knows the basic concept of networking and also the design on operating systems, kernel 11, all these things, their ability to take those software security courses in their senior year to be ready at least when they get into the workforce community, they know about it, which is kind of a undergrad side. But overall, unfortunately, we don't have an ability or teach it or sharing with the communities undergrad level for software security, which is sad. I wish we had more, but there's some kind of constraints and not able to achieve the security courses. Another constraints that I have been seeing at undergrad level is teaching about more what it is in terms of the concept, in terms of abstract. There's not much courses about how it is, how it can be done. So what it really means, like, it is more theory. It's more about, hey, I'm going to create an operating system. So in kernel level, I'm going to create some data algorithms. It is focused on more about abstracts and theory, building up an engineering capabilities. Now, when we look at the secrets shit more kind of a on kind of a more living things, it is very difficult for faculty member keeping up to date. What is the new threats? What is the new problems? You and I, we have been in the domain for years. We know what type of potential threats we might see. We know the trends because secrets keep changing every 6 months, as we know. It just keep things coming up. It's very difficult for undergraduate professors keep it up to date and changing the curriculums, get approval every time, which is another constraint. It's kind of, yes, we would like to do, we were wishing it, but it is difficult. So what I do in the graduate level, Chris, and I kind of revise the content every semester, not every year, every semester. Look at what are the trends looks like. What are the adversaries are taking advantage of this new domain? Like today, maybe Docker Kubernetes. Now, next year may be different, something else. So really, I'm trying to get more into the relevance of the security instead of teaching something like outdated 4 years ago. Still, it's relevant, may not be relevant as 10 years ago. So it's more kind of connecting the real world scenarios, give the reason or give some incidents to the student. They can analyze, they can see what's going on. It's more kind of an up-to-date information is required to really get understanding security concept. Goes back to your analogy at the beginning, Chris. We don't want to just teaching the students just writing the security coding. We have to teach why is important.
Yeah.
What is the impact? Where can I use? How can I think about the complexity? What the relationship looks like? Yes, we have to write the security coding, but we have to know why is important. I'm going to stop here. So otherwise,
and I think, I think there is a lot of room in academia to refactor. There's a good development term, right? We need to refactor what course material is going into a CS program. If it means we got to take something out to get the pieces of security added in, then that's what needs to happen. Because when I think of things like input validation, right? A secure coding with Java course or secure coding with Python, we should start with input validation before we even let them take a single line off the command line. We should have a lesson in input validation, because input validation is really the genesis of almost every class of vulnerabilities we have in the world of web AppSec. It's because somebody didn't validate the input. And there are things you can do in an object-oriented world to attach, to define fields and define the characteristics and shaping input. Maybe that's a more complicated term or a complicated thing, but we can do some basic input validation before we even let somebody do a single line program that grabs input from the console, like so that they know what that threat category looks like. And so that's what I want to see from the world of academia. Is it's time for academia to catch up. And I commend you. You're teaching you're teaching at the graduate level the things that we need people to come out with graduate degrees in those things. I just want to see it sprinkled across more anybody who's writing code, because I think the boot camps are starting to catch on to the importance of security.
It is, Chris, and other things I would like to share with you too, which is kind of a parallel things we have been trying to do in the communities, front runners. We are trying to bring the security concept, as you mentioned, about the input validations or sanitization, time to check, all this concept that has to be taught when we are teaching the language at the undergrad level, to make that awareness of the faculties as well as the researchers. Now we are trying to build up some workshops of each conferences, like research conferences. The workshop, the students usually will there as workshop participants as well as the faculties try to connect the real world problems with the researchers, academia people, let them be aware of what is going on. Like the kind of one study I have done, look at the common vulnerabilities. I came up total 24 vulnerabilities we are talking about. Look at every vulnerabilities in an NVIDIA database or CVs. It came to about 24, like input sanitizations and checking the times and password privilege, etc. It is independent from the language. That was what doesn't matter what language you're using it. So kind of building up a lot of workshops under research conferences and create some awareness for academia as well as the students who are pursuing their PhDs or other type of degrees as part of the after graduate undergraduate program. So there is awarenesses keep growing, and most of the research conferences are opening up a venue for a practitioner, Chris, which is a great thing to see. The practitioners also becoming a part of research conference to share the real world scenarios. What is really happening now? Which is connecting the two worlds. Like next week, I'll be at Italy and talking about the ARIS conferences. I have a specific workshop session talking about DevSecOps, talking about AppSec, describing what the potential problems that we have been seeing in the community. How can we get the researchers focusing on today's problems and deal about and educate the people, educate the students, they will be ready for course. It is getting, but it's not there yet. I agree. We have to do more work down the road. But at this, we should start to work in that direction.
Yeah. Yeah. So I think it's time to talk about SBOM. So Robert, take us into SBOM here.
Okay. No, it was great conversation. Just quick aside, I'm also working on my PhD and I got my master's in cybersecurity as well. So, I've seen some of the same things that you've seen, and so it's been really interesting just to sort of aside to talk about that. Let's talk about SBOM. So how did you get into SBOM, and what drew you to focus in on that area of security?
Great. Thanks, Robert. So it goes back to my CMU journey that I started when I worked in the DevOps. The first time when we would try to do infrastructure as a code, we were not really calling SBOM at the moment, but we were talking about software supply chain as part of infrastructure as a code, as part of the deployment scripts, as part of the build scripts, and creating those artifacts. So we were using as part of a typical DevSecOps practices and collecting the build artifacts, storing the artifacts in repositories, look at the dependencies, creating an environment parity. Now, when we start to see more communities driving those automation practice, and White House ordered the software bill of materials, and because of the SolarWinds case, everybody remember that story, that became a kind of yes, we have to create an SBOM. But the one thing that bothered me, and everybody looked at SBOM as just a file content, creating a file that we are done. If you have a file that I know, that means I'm great and I know everything else on the file and the dependencies. But people never thought about it, what the version that we are doing about SBOM, how we generate those files, how can we use those files. So that type of problem attracted my attention as I said, no, as a community members, I have part of CMU. Let's talk about more what really SBOM it is. How we can use those files, where we can utilize it. And all these questions needs to be answered. Then I became kind of another person in that community and putting the red flags. Hey, stop. If you're talking about the file, CycloneDX or SPDX, let's stop. Let's talk about what it is, where we can use, how we generate. That's the reason I'm part of that SBOM community. Talk about it, share some examples, tell the people what it is and how we can use, where we can use. And these are the things that attract me. That's the reason I'm in the SBOM world as application security perspective and utilizing the modern software language and technologies. That's the reason I'm kind of getting into the SBOM.
Mm-hmm. And I know we've heard in your history, you talked about some of the complex systems you've been involved with throughout your career. And I can see how complex systems, it's hardware, it's software, these are going to be challenging in regards to SBOM and AppSec. Can you share a story with us about how SBOM plays out in highly regulated environments like Department of Defense?
So it's a big, I will say either a mess or a problem, both directions. The problem is we are not just dealing with one type of application set, Chris. When we talk about the complex systems, think about any aircraft. It doesn't matter what type of aircraft it is, or think about any missile. It doesn't matter what missile it is, or the satellite. There are many components in that such systems. So each of the components not developed as single vendors. Multiple vendors are contributing. So multiple vendors are contributing either as specific languages they may have, even though some of the systems have still Ada or a Fortran. And some systems has Rust or AngularJS. So see the complexity, it's a lot. Like we are dealing about a very, very old archaic language versus we are dealing about so much modern languages. It is not just always a container-based application we are talking about. There is a real-time operating system. So complexity is more about the different components in the systems. So when we look at the different components, it is becoming a nightmare of looking all those dependencies, finding out. So like if vendor is developing one of the components, they may not be delivering the code along with the artifacts. Probably they have some secret sauce in their modules or the dependence, whatever they are delivering the part of the complex systems. Let's say like we're talking about aircraft radar as an example. Whoever building about radar system, they don't want to share how they build it because there's a lot of kind of company property information in it. So they don't want to share the SBOM, or they are sharing the artifacts as the binaries. How much do we know that binaries is built based on dependencies? We don't have it because they're just sharing how they build it, but it's very limited. So when we look at the complexity, usually in that systems, we are looking for the first order of the file dependencies. We don't know the second and third order. Because usually it's built, it's shared with the artifacts. So when we look at the web technologies, usually we're kind of building the components. We know how it is built. We know all the dependencies from the perspective. But in the complex system, we don't build all the time. We're just getting vendor drop. Vendor drop has artifacts as binaries, and here's SBOM. We don't know the second, third order. The second problem is when we get those files, how can we protect those files? Where we can store, which is a lot of policy or the risk people they don't want to share, even though it's not kind of everything else what they share as part of artifacts. It's becoming a very challenging where to store those SBOM files, how to utilize it, where we can put it, which is protecting those SBOM files. The third one is once we get all together, let's say we're going to analyze some of the dependencies. If it is conflicting each other, let's say I have the one versions running in such systems, the same version running in other components, can we update those systems automatically? Or how can we maintain it? If we know it fine, but can I update it? Can I address those vulnerabilities? When I look at it, now, is there any process to update those vulnerabilities? Probably can update an Artifactory, but when we talk about updating automatically, it may not be easy. It's a very difficult job. Fourth element is about the approval in Department of Defense and high regular environment. Every piece of software has to be approved. When I say software, actually, I'm talking about the system level. Every system has to have an approval that goes into a field, and soldiers and mission operator, they will use on the field. To have the process we call as the ATO, Authority to Operate process, now we have a continuous ATO, it is requiring so much checks and validations of those dependencies and risks. It takes longer time to get an approval. There are many, many reasons we can discuss in another podcast why it takes longer. When I put myself in the situation as the AO person to approve, authorize the systems, if I don't know the components, I have to test it. It will take longer time to test those applications for certain vulnerabilities. So it's creating a very complex situations, building hundreds of files, not just building, just somebody's dropping. Now, if I am a person analyzing all these dependencies, how do I know that? How can I verify it? How can I validate it? How can I test it? It's becoming very, very complex situation, Chris. So there are some movement happening in the kind of a more public version information that I can share. There is an Iron Bank container, maybe you heard about it. So Air Force decided to build up a containerized versions of every component that we use. Let the vendors going to use those containers as we know at the beginning. Let's say I'm going to build up a kind of like maybe the Rust container or the Python container, whatever the language that people would like to use, build up a container version of that environments, sharing with the community, that community who are using those libraries to build up the systems, at least to solve some sort of material problem at the beginning when we are trying to build up the components. But it is not there yet. It's just a start to solve the complexity at the beginning of application or system creations, which is more software side. So when we look at the hardware bill of materials, it's another complexity that we have been seeing it. So we have so many hardware components. How do I know that the hardware component that we are building, we have a traceability of those hardware bill of materials? So now the is actually talking about XBOM, including just saying S or H, we are saying XBOM for everything else. Use that concept as keep tracking the hardware components, keep tracking the software, building a configuration management concept as keeping the same version, at least to solve the complexity problem. There's a lot of work needs to be done, but it's very, very challenging. It's not as kind of thinking about, I'm a web application, I know every file, I can build automatically. We're not building everything in the DoD context. We are a consumer of the build. When you're the consumer of the build, then how do you know that the SBOM is the true SBOM that you are getting it? How do we know that it's actually the right file? How do we know that we're going to use and protect? These are the typical challenges I have been seeing, Chris.
So
it's very, very difficult. And comparing with a typical web application, like as I said, I'm sorry to interrupt you, Rob.
No problem.
The one of the aircraft, we are talking about more than 1,500 components. It's a lot.
Yeah.
It is difficult. And 1,500 components, 1,500 vendors that talk about that perspective, maybe more. It's very difficult.
Definitely.
Yes, Robert.
So Hasan, you've talked about or mentioned the term actionable SBOM. I wonder if you can take us through that a bit. But also, you mentioned XBOM, another type of SBOM, maybe some other types of SBOMs, but in particular, actionable SBOM. What do you mean by that?
Great. So when I look at the DevSecOps concept that we have been advertising and working a lot, and a little bit background for both of you, as the SCI Software Institute at CMU, we are architecting DevSecOps infrastructure, many DoD programs, many organizations we do. So what it really means, like we are creating the infrastructures let the vendors as well as the internal developers, they can use infrastructure, DevSecOps pipeline, CI/CD pipeline to build up the systems to verify and test it and integrate it. So when we look at the perspective, going back to the reason why I'm in the SBOM domain, seeing that the file as the deliverables doesn't mean anything. We have to use those files in our analysis. We have to generate those files if we are able to build it. When we'll have the file, we have to know it is aligned with our application artifact version together that we push into the deployment environment. When I said actionable means, we don't want to treat SBOM as a static file, stays in repositories or stays in the artifactories. We would like to use those files as part of our infrastructure as a code. We have to use those files, somehow integrate our deployment scripts. If I'm using the Docker containers, I want to make sure that my Docker container are aligning with my SBOM file that I generated. If I'm using my infrastructure as a code to the provisioning of my test harnesses, and I would like to make sure that the line of the infrastructure as a code, like all the provisioning and all the configuration item, should pull the libraries align with the SBOM file that we have, which is more constructing infrastructures or versioning or environments. Now, if I am using those files, I have to monitor it, how it is working in a production environment for the vulnerability perspective. That means I have to monitor it, look at all the files, monitor for the new vulnerabilities that keep coming up, and I have to use those vulnerability management software. We have a lot of vulnerability management software. That has to be aligned as well so we can monitor it. We can go back and change it if it is required. But to have those changes, really we have to make sure that it is kind of created as part of our artifact together, as had to be versioned together. So versioning just the file itself is not enough. We have to create a package as code. My dependencies in SBOM, here's my deployment script, he's running in the production environment. That's kind of using the file as we are creating, as we are building, as we are deploying, as we are testing. So these are the things that actionable means that we have to use as we are doing the daily process.
How does that work? How does that work?
Chris.
Let me just ask a question here because I'm trying to understand actionable SBOM. So How does that work using that artifact when most of the software that a company buys/consumes comes from another vendor? So most of the software that I get SBOMs for comes from a SaaS provider that I'm not building the software, for example. Mm-hmm. Right? So how does actionable SBOM help me in kind of what I think of as the majority of the use cases where I'm not building the software myself?
Great. So perfect. I'm getting DoD is actually fitting that case a lot. I have to get those files, but I have to create a use case what I'm going to use. How can I monitor those third-party libraries in my SBOM file? That means I have to connect the file that I received and align with my monitoring tools, whatever the monitoring that I have, looking for my production environment or the components. If I have a vulnerability management software, that software should look at the files that I got it from a specific project. Like as we know for the Log4j as an example, right? Log4j, one of the problem, people couldn't find where it is. Do we have a Log4j? If we have it, how can I fix that Log4j? So going back to SBOM, if I know the SBOM, if I have a versioning is created with all the artifacts, again, I'm not building, I'm just acquiring the software from third party. I have a full transparency and full traceability of my product that I got from a third party vendors, running in which servers, which infrastructures, which machines that I'm using it. I have a traceability of where I deployed. That goes back to the deployment type. I know exactly where I'm using it. And I know exactly I'm keep monitoring the files, which is kind of actionable, means I'm going to monitor those components, all the libraries. And other things is important, like sometimes we see interdependencies. We have one version, another version, maybe their subversions are conflicting each other. So I have to look at those files as well. If I'm running an applications in my single server has two products are running in the same server, if I have a conflicting version of those dependencies, I have to know about it, because if changing something, it may be okay, but it's going to break other ones. Mm-hmm. So it's more about the visibilities and transparency and also traceabilities of each of files and how we get it, where we use it, how we monitor it. Each of them is requiring an end-to-end lifecycle thinking, Chris.
How does that work from a speed perspective? So one of the challenges I've had with SBOMs has been the government's come out and made these requirements that say we have to have SBOMs for all these things. Anything the government buys has to have an SBOM. And I'll tell you, I'll kind of read back to you what I think is happening with 99.9% of these SBOMs right now. The customer that's buying software says, I need an SBOM. You just send it to me. And they're taking that SBOM and they're putting it on a file share somewhere. And they're never going to do anything with it again. And so, but what about a world where somebody releases software 50 times a day? Okay, so like SaaS, like even most startups that reach a certain level of maturity get to the point where they push software multiple times a day. Let's even say they do it 5 times a day. How does that work in this scenario of actionable SBOM that you're describing for me? Can actionable SBOM keep up with 5 releases a day? Can it keep up with 500 releases a day? Does it break at some point? What are your thoughts?
So when we look at the monitoring and traceability aspect of it, Chris, we can handle that. I have been demonstrated already in many use cases. What do we have to do as a secret? Once we have the build artifacts of any systems, any product, the file has to be treated as our artifacts. We have already have an automation of artifact collections. Like we build an artifact, that artifacts goes into the artifactories, right? We know that. We have handling. We have process for continuous delivery and deployments. We already doing all these CD practices as the speed of delivery. But we have to treat SBOM file as part of the package of our binaries. If we treat that, what that means, we have to create SBOM file as we are creating artifacts. When we are putting artifacts into artifactories, we can use the SBOM file as part of artifactories. We can use the same artifactories that we can collect it, put it. When we look at the deployment practice, we can attest, we can verify the content of the deployment against SBOM that we created, which is easily coming. There are many, many tools available in the community that tools will help us to integrate. The key point is here, Chris, we have to integrate each of the steps in our pipeline. We have to think about SBOM as part of the code. Once we think about as part of the code, how the code is following those steps, we can automatically keep the SBOM as part of our code, how the code is tested, how the code is deployed. Absolutely, we can handle the speed of utilizing those SBOM files, utilizing as part of our factories, utilizing as part of our dependency tracker, utilizing as part of our code analysis vulnerabilities, like using the bomber as an example, or using in-code attestation of looking at the file content. So there are many tools available. The key problem is we don't think about as part of the code. We never really integrate those files as part of our function together. Just one-on-one things in the configuration management aspect of it, Chris. CM practices says you have to take every components as the individual items in the code base. When we say item, the item is not just the binaries. Item is the code. Item is the SBOM. Item is the dependencies. So one-on-one configuration management is actually dictating us to trace each of the items all the way to the end in the production environment. But what we do as a community, we're just creating a file, keep it in somewhere else in the shared drive, then never able to connect our pipeline, our infrastructure, our deployments. That's the problem we are facing right now. That's the reason we cannot handle in this scale. That's the reason it's becoming useless. What we have to really think about as part of our code. Even though we can think about early in the life cycle, the design phases, Chris, which if you look at the CISAs, the different type of SBOM, there's a design SBOM, there is a source, there is a build. Each of the SBOM is actually, we are creating as we are building an application. If I am acquiring a third-party libraries, I should be able to create a design SBOM as soon as when I'm acquiring. If somebody is changing one of the dependencies during the build phases, I can verify it for a licensing perspective. Mm-hmm. I can verify that organizations, is this my developer are using the file that I acquired, or they're getting somewhere else? So we can really connect each of the phases. But what we do, my opinion, we never really think about this life cycle. We always think, oh, I have a build time, someone's going to give it to me. So be it. If it is the shared drive, there's no benefits.
Yeah.
If it is the shared drive, there is no we can scale up. It's impossible.
Yeah, and it sounds like you are kind of of the same mind as I am. SBOM is valuable, transparency is valuable, but it has to have action associated with it. Yeah. It can't just be another file that sits on a file share somewhere that's just never to be acted upon. Okay, I think we got that one. I think we got that one covered. Let's Robert. Let's go into our lightning round here. I'm very curious to hear Hasan's answers to our now famous lightning round questions. I don't know why they're famous. I just declared them famous, but I can do that.
All right. So Hasan, we have 3 questions. So the first one is, what's your most controversial opinion on application security, and why do you hold this view?
So one thing is we always trust the static analysis result, and we always following what the static analysis tool says to fix those vulnerabilities. My biggest problem is we don't know what is enough. Do we have to fix everything? What is the threshold of saying enough is enough for fixing those static analysis finding?
Okay.
What that really means? Do I have to fix everything? What the tool says is a higher? Or what matters to me? Which is people are really getting in a trap, try to fix every vulnerable as what the tool says.
Very true.
It really matters to what the risk that we are dealing about it. It matters what organization risks are. We never think about that perspective. We always say, yeah, I do, but never, ever. I haven't seen any organization are really linking those findings, scoring those findings based on their organization risk policies. It's bothering me. I don't know how I can fix it. I don't know, but we don't know what's enough is enough.
I hear you.
One day we will do, but I don't know when.
So our second question is, what would it say if you could display a single message on a billboard at the RSA or Black Hat conference?
That's a tough question. You know what? I'll say we are in this world together. build safer world all of us will live for forever. Build a safe world we can live for forever. That's my vision. That's my mission. How to get there? Works together as a team. Let's build up a safe world together to live for forever.
Excellent. And what's your top book recommendation? It could be related to security. It could be another topic. And why do you find it valuable?
So I have been reading actually 2 books just came out recently, and one is a software transparency and from Chris Hughes, and he's a good friend of mine. Finally, he's talking about the similar this thing we discussed as of today. It's about transparency and how it get there, how can we use, how can we make it transparent for everybody else. I like that. The other one actually is kind of I like that about the cybersecurity first principles, and from Rick Howard. And we have to really understand our strategy and techniques and ideas. Then we can really build up our why. Why is important to us? What is the strategy? Without having a strategy, it's very difficult. We always kind of becoming a more reactive. We would like to be a more proactive role. And I believe the cybersecurity first principle will be going to let us to think about more proactive instead of being a reactive role.
Very nice. Very nice. That's our second or third time the software transparency book has been recommended. So folks out there, if you haven't read it or bought a copy and read it yet, it's like the third time you've heard about it. So I don't know what you're waiting for here. But Hasan, how about a key takeaway, call to action for our audience here? We talked about a lot of things. We talked about Actionable SBOM. We talked about F-16 simulators. We talked about the future of higher education. What's a key takeaway you want to leave our audience with?
You know what? Key takeaways, I always say when I was kind of dealing with my students or dealing with the higher ups in DoD, I always say we are dealing with the security. We are dealing about the problems every day. But we have to learn how to mitigate, how to navigate in this complex world, in this complex security settings. We have to know the risks. We have to know about it. We cannot say like, I'm going to stop everything, don't do it. It's not the right way to think about it in security perspective. We have to learn as a team-wise, and how to navigate these complex situations and with a secure mindset. How can we do? With just the talking and sharing. That's one of the reasons the podcast is important to learn from each other. We're not alone in this world. Somebody somewhere else dealing the same problem, maybe they're talking the same topic. So being a good ethical persons, let's work together.
I think that's a great.
Let's share the concept and idea so we can get better as a team.
Yeah, that's a great.
Instead of silent.
Great thing to leave us with. Let's work together. Security is a team sport. It's not an individual activity. Exactly. We can all help each other to solve problems, and we can learn from each other along the way. And so, Hasan, it's been an honor to learn from you here as a distinguished professor as you are. Thank you for coming on the show and sharing your wisdom with our audience, and even teaching me a little bit about F-16s. That was one of the coolest things.
Thanks for having me, and Chris and Robert. Thank you.